Test, 1, 2, 3, 4. Vague audio. YouTube says I'm streaming now. I know I still need to get a better microphone. You know, all the good news. Cool. Woohoo. So, I'm Ray. We're building the dice, which is a very, very small, precise 3D printer of epic proportions. No, it's very small, very precise, hopefully very fast, and lots of fun. So, let's get into it. This is vaguely where we left off yesterday, last time. So, the first thing is the X carriage here. I have two belts that are glued in on this side, on my right. So we're working on this as well. We ended here because despite the fact that super glue sets in about 10 minutes and we glued the belt into this blue piece here, despite the fact that super glue sets in 10 minutes, I wanted it to sit for 24 hours. Also because I did not have the proper clamp prepared and I needed to play with these things a little bit. So eventually I found a basic clamp like this. Let me explain what's supposed to happen. The idea is that I need a glove, otherwise the teeth dig into my fingers. The idea being, one at a time, we're going to hold the card here and we're going to tighten up our belt. And we'll tighten the other as well. Tighten the belt. We can pull the card over here, all the way to the end. Come on, we got you. Okay, wonderful. We can do this, and we tighten the belt. And then, with the belt tight, we apply the clamp. The problem is this. Once I let go, the belt starts going through here. In other words, the clamp is not holding it tight now. So, watch. Do you see how the belt has moved? It's not tight enough. It's not holding the belt as tightly as it needs to, because it's slipping. So, despite these things, and if I let it sit for a few minutes and I put slack in the belt, there's already this much, but we get millimeters more. So this isn't working. So then if you Google Dice 3D printer, the first result, or one of the first results, should be the Instructables with the videos, but one of the other results is a Thingiverse link with the dice helpers. And this is one of the pieces in there, and essentially it's a belt tensioning thingamajig, a helper. The idea is you put this over the blue, and there are slots in here, 1, 2, 3, 4, with teeth that grab onto the belt. And this lets you keep the belt tight while you glue in the other side under tension. Because we only have a few millimeters to move these motors inward to tension the belt after the fact. So it has to be pretty tight right now. Now, naturally, this, I got it pretty tight, then I was still able to pull the belt out approximately 5 millimeters like that. So, I said this is no good. I don't have local access to a much better clamp than this. I could try some C-clamps, but it gets complicated. This printed part, while it does work for some people, is causing me more pain than success. So what I did is I took the OpenSCAD model for this and I modified it. Essentially, I split it out, and it's printing right now, so I need to stall for approximately another, I don't know, 20 minutes or so, maybe. What I'm getting is just one half of this, so one tooth block section and no floor. And I'm printing two of them. And what we're going to be doing is we're going to use that as the clamp. So I'm going to tighten this up. Hey, come on, we can do this. There we go. Come on. So I'm going to tighten this up, and then when it's done printing, we're going to put that piece on here. And these teeth of the belt are going to continue digging into my skin and causing me wonderful amounts of joy. Yes, joy. Joy is the word for pain during happiness, right? Yeah. However, since I'm stalling, because the printer in the closet area behind me is still working, we need to backtrack and do a few other things. Yes, because we need to do them. In a previous video of sorts, we installed / I briefly described how to install, and then didn't actually do it on video, these 4 pillars. 4 pillars. Woohoo! However, as it turns out, I did not actually Loctite in these 8 nuts that hold the M4 screws, which retain the flange bearings. So we need to apply Loctite. And in order to reach inside here with the Loctite application, I need to remove the pillars. So we're going to be doing that. Or at least these inner pillars. I'm going to prop it like so. I'm going to insert, there's a hole here, I'm going to insert my hex key, despite the fact that these are Torx screws. And I'm going to unscrew. And I will remember that I've placed it down this way, so that the orientations will later match. I now need to extract the screw. One moment. That's one. And the same here. And 2. Wonderful. And let's remove the screw. I'll just go right with the pliers because I don't want to drop this one in as well. Okay, there we go. Hopefully the thread was not too damaged by my light gripping there. Again, stalling, so I'm going to have some water. Okay. So, now I can put this back, like so. And I relatively have access to my 8 screws. Relatively. Start with the outside. What are these? 1, 2, 3, 4, 5, 6, 7, 8. And all we're going for here is finger tight and just a little bit of Loctite on the thread here, so that, maybe I'll do it standing up. Maybe. Guys, maybe. All we want to do here, just a little bit, we're not going to over-tighten the nut, we don't want any compression, we want the flange bearings to spin freely. We just want a tiny dab of Loctite to keep that nut from coming out. So we shall do that. I'm working on being able to, there, the moment I say tiny, I didn't even get to say it, I just want to apply a tiny amount of Loctite. Alright. Going with the paper towel, just want a little bit. And we thread it on, and all I'm doing is finger tight. Alright, next victim. There it is. Ever present. It's all we... There we are. Wipe the surrounding area of aluminum. Tight. Other side. Okay, that's the drop. That's a lot. Alrighty then, and that's even more. Okay, we are definitely wasting our fair share of this here. We gotta lie this down now. And we gotta wipe it off all the places. And that feels great on the skin. And we apply it. Finger tight. Wipe more. Oh. How much is this leaking? Why is this leaking? Is it all in the cap or what? I don't know. Yeah, this is quite wasteful, I must say. There's some on my table. This is a dream come true. Okay. That was 4. I think after all I'm going to remove. Do I want to remove the rear pillar? No, I can do at least these 2 without removing the pillars. Okay. Then we'll see. Hello, whoever just joined the stream. Please say hello. We are presently watching me struggle beyond belief with the simple Loctite. Try not to hurt anything. And we have leakage. I don't understand how, but okay. We'll just dab it on. Finger tight on the nut. This one already came off for us. Perfect. Okay, that's a way of doing it. Finger tight. And the other side. Looks like one nut already fell off. Turn this. Alright. Okay, that is a very, very light trigger press, resulting in a lot of gluing. And last one. Finger tight. Go back for another pass. There's finger tight. Okay. That concludes this particular adhesives portion of today's stream. I'm just going to clean up the threads here. And now I will go wash a lot of very expensive blue residue off of my hands. I'll be back in a moment. But first, we check on the printer. And our print is finished, but the plate is still warm, so we'll let that cool down for a bit, and we're still working on this, so we have some moments. I'll be back in a moment. Wonderful. I'm back. We'll now remove the bent gluing pods. The closet of printers, to be shown at a different time. Interesting. So, we have, what do we want to call it, a belt shark tool thingy. It is this item. It will quite literally take a clamp, take a belt, and the teeth will go onto the belt, and it will hold the belt. As such. See? Boom. Now, that is as far as the belt will go. And these are prepared. Cool. I have a feeling that this will be slightly kinder on the belt than the previous option, than the actual clamp. But we've got very expensive belts here, the Gates Power Grip GT3, so you know, it will work out. Okay. Now is a good time to put the pillars back. So start, I already lost the screw. We just tip it upside down and let the screw fall out. There we go. I'm holding it. Get the wires out of the way. Let's try this again. We insert the screw here. We have a hex key through here, despite the fact that it is indeed a Torex screw. We have a ground flat section. See, we just took a file and put some chamfers through, and that goes towards the inside because, as I covered in the previous stream, there is a screw head there that we do not want to interfere with. I'm not over tightening by any means. I just want it there. I can come in with Loctite or a proper Torex bit later. And yes, it will resolve. Okay. And we go again. On this side. Alrighty then. That brings us back to here. Let's take a moment to, probably should have done that before installing the pillars, but you know, take a moment to clean off the glue residues. Yeah, that would have been a great idea before installing the pillars. Oh well. It's okay, the outside area, and remember this is the bottom of the printer, so nobody's going to be looking here, but the outside area came off very clean, and the rear area, where it's even harder to be looking, although I might be wrong, came out a little messier, but it's okay. Remember, if this is how I've done it, you can't do it worse unless you're really trying, you know? Really trying. Okay. This is our belt system. Remember, these belts are glued, so we're good. Now, however, we pull these belts, and the card goes all the way there. And then I can put on my gloves, and I can pull these belts. And indeed, we might be doing this. Let us observe. So I'm going to do this for one at a time. Set this belt aside. Tension this belt as much as I can. And install a clip. Verify the orientation of the teeth. Okay, and now we check it. And I can pull very much even less. This is good. So now, we're doing one at a time. This is important. So the belt goes here. I'm holding it, and see I have this tail all the way out here. But we only want approximately 10 millimeters the depth of this. So I will get my 10 millimeter measurer. AKA my pre-adjusted caliper. Okay. Approximately this much from the edge. And we will give it a cut without any preparation whatsoever. I'll be trimming this slightly, I presume. I just cut a very expensive section of belt. Wonderful. And now I shall insert this in here. And we observe that it does not go all the way in, so now one tooth at a time. I shall trim it. This is getting quite close. I'm not sure if I want to trim another tooth. I remember seeing in the gluing videos that there was some slack. I will consult those videos now. Glue the belt in. Step 10. We've advanced into farther steps with the pillars and the Z-plate, but I have taken the gluing of the belt slowly because I want to make sure that I do it correctly. And this video is fraught with complex adhesives and other items, and we are just using our cheap super glue. Quickly we will also check that the other hole accepts the belt freely. This is good. Yeah, I'm comfortable with this. I think this will be good. Hang on. Oh yes, now is a good time to check that the belt is actually going through all of the flange bearings. So on the front side closer to me, we're good. And on the rear side, yes, roughly, we're good. More or less. Hopefully more, but unknown. You can even feel the yellow part is under pressure. And now is a good time to adjust the GT2 pulleys as well, because we're under pressure. So I have to move this guy up a little bit. Yep, that's the one. We're good enough. Can't really turn it right now. But I see that it is compressed slightly. That's good for me. Later, after it's glued, I will do the second set of screws. We can do the other one a little later as well, but close enough right now. Ah, so they want 8 millimeters, not 10, my mistake. Yeah, we don't want the belt going all the way in. So 8 millimeters, I will adjust. Good thing I watched the video. There we go, we got 8. Yep, that's roughly 1 tooth too many. Okay, now that will go all the way in. This is good. And then I don't understand the rest of the video, but some various things that I don't understand. Yes, that's all it takes. The important part was discerned. The important part was discerned, that we indeed want 8 millimeters past this edge of the printed part, and so we will do full in. Whatever wording we want to use here. Now, we apply a decently large amount of super glue. Okay, I'm not in gloves because this does not, despite me putting it airtight into a bag to the best of my ability, it does not want to work. So we will use the pliers. Right. Yeah, so super glue really apparently is a one-shot deal. As much as you try to preserve it, this time it did not work out. Okay. This should be done on a paper towel. There's already super glue. Aha. On this paper towel. Very good. Okay. I guess we will be applying this raw, and then that will be the end of this amount. Okay. On and off camera glove application. That's roughly 4 teeth worth. I have to give that a moment, and then I do the other side. That's going to drip. Decent size, and then I go back and I put a larger glove on the tooth side. And give it 1 moment. Just a moment, because it is going to drip. And I let it drip, and then right away, I put it in. And I got 2 teeth too many. But yes, I put it in. And I close my super glue. Yes. Okay. Alrighty then. We're going to let that stand for 5 minutes, shall we say? Cool. So it is just about 8:30 p.m. right now. I'll let that stand for a few minutes and I'll be back. I am back. So we are partial. We are 3 minutes into the glue drying, and while it could be 5 to 10 minutes, I want to make sure that it's very good because there's going to be a lot of pressure on the belts there, and we want to do it right. So we could potentially move this to the side a little bit, and I'll put the super glue back in the bag because I do need one more use out of this tube. Without air, without air. Get rid of the air, come on. Okay. And we shall move this one out of the way for the time being. I will now consult the instructions videos, and I also have a chat with Renee, who explained to me something about this Z-rail, or how do we say linear rail in German? Let's see. Lineation. Lineation, it's linear, linear, but in German you do not roll the R. I'm Russian, so it is my habit to roll the R, but we do not do it. So the only way I know how to not roll the R is to make it a very soft, under-emphasized R. Linear, slight R, linear. Shine, shin, S-H-E-I-N-E, lineation, linear rail, shin, lineation. This is the best I can do off of hearing it said once. Lineation. I will be criticized for this later. So I will find the Renee tutorial is a word that he used in this. Cool. It says, do it like in the video. The first thing is to mount the rail onto the... I will get it. The first thing to do is to mount the rail onto this. This makes sense. Saves me 15 minutes of fumbling. I like that return on investment. So, yes, we will do it like that. So we have mounted the vertical pillars, and now we can mount the Z-sheet. So we have skipped from step 10 now to step 12. The Z-sheet. Change my subtitles to English. A T10 Torx screwdriver, which I will find. It's one of these. 8 countersunk M3x10 Senkkopfschraube. This screw. Senkkopfschraube. We have our rail already in here. And I will slowly work through the YouTube video as we do this. From last time, when we do this, we want this to cleanly exit. And is it cleanly exiting? Sort of. Slight slag, but it's okay. It does not matter. This is fine. Okay, so the instructions currently suggest to put this sheet, just this sheet, onto the inside of the build. Not yet ready to do that because still gluing the belts. Now this will be the next part of the installation. What I can do in the meantime is I can assemble the rail to this 2mm plate. Remember, we have another one that looks like this, but this is the shorter one. The longer one is being used for the x-axis. That, I would believe, is a 140mm rail, while we're using a 120mm rail here, I think. My ability to make up numbers is very good, so do not quote me on this. But yes, this seems to be the general idea. Now, we've lined this up to some extent. We'll be working on the side, I think. Now, I will assume that we use this screw and this slotted nut, M3x5 on the screw, 3x5, by 8. Random stuff. H to D. 3 by 6, M3 by 6. Is it M3 by 6? I check. Seems to be M3 by 6 then. Okay, this will work. I thought we had some M3 by 5s. I can consult my diagram. This is step 12 or 13. Mounting the z-axis, M3 by 8 cheesehead. 7 of them, yep, by 8. No, hang on. Oh. M3 by 6 cylindrical head. Mounting Z plate, sink screw. M3 by 8. Hang on, I will go to the next step where we have the linear rail option. Yeah, step 13 is the one where the linear rail is attached to the plate, and apparently this is a 140 millimeter after all, which means I'm very good at some item. So they're suggesting to use M3 by 8 here. I have to check this. This is M3 by 6. Ah, yes, I remember now. This is a difference because in the instructions they use, in the instructions they originally used a high wind rail, and we're now using a Masumi rail, which is less tall. So we substitute the M3 by 8 for M3 by 6. The memory has awakened. Okay, cool. So I have my, one moment, come on, we can do this. I have my Schlitzmutten, 7 pieces. I have my M3 by 6 button head, or as they say here, cheese head, Linsenkopfschraube. I already have one prepared, and I need 1, 2, 3, 4, 5, 6, for a total of 7 M3 by 6 in this case. Button head Torx screws, and 7 Schlitzmutten slotted nut. Schlitzmutten, plural. 1 Schlitzmutter, 7 Schlitzmutten. Or plural, as the case may be, Schlitzmutten. I will start 1, screw in the corner here without watching the instructions even remotely. I will lightly screw it, I'm going to keep it loose. I will now do the other side the same, starting with the screw. Oh, and we do not want to lose our cart. Which is why we go sideways instead of up and down. Yep. Still wiggleable. Smooth is good. I will watch the video. Seems like we're also going to be using M3 by 6 cylinder head, Zylinderkopf, or yeah, Zylinderkopf, 4 pieces of that, M3 by 6 cylinder head. And then this step 13 also calls for the currently out of view print bed holder. Yeah, we're not there yet. We got some filing required, you know, that'll be next time. But this time, not so much. Anyways, we're going to keep it loose because I once again do not have the patience to read through the subtitles. We're going to install all 7 screws. I'm going to drop the slotted nut in. Drop in the slotted nut. We're going to begin screwing the screw. We're going to do this for all 7. We're going to keep them loose, and we will tighten later. So tight, and then back off by, say, a quarter turn, and then alternate, going back and forth. With the Schlitzmutten, the slotted nut, there is a line, a cutout going on one side, and we want to keep that on top because when we tighten, we can put a special tool like a fork, or in my case, a flathead screwdriver, to keep that in place as we work on it. And we continue. And the last one right in the middle. Yes. And again, we can wiggle the rail. This is good. Loose is good. But it is now attached on the plate. I check the time. It is now 8:45, 15 minutes. Super glue seems hard. It is no longer sticking to me. I try to pull the clamp off. Or maybe I leave the clamp on for reasons of no reason. And we check the teeth side and we see if we can do the second one at the same time. Just check. And it's a bit tight. I don't feel like it. Yes, I see. My head is interfering with the entire shot. So yeah, we will pull this. Yep, this is now under tension. Fine. Okay, 15 minutes. We'll see if that pulls out. I'll try not to agitate it too much. Okay. Now we can use the same piece over again, presuming you didn't just magically drop super glue on the opposite side of where you need it. And now we check. This is the bottom belt. I'm plucking it and it's also good, but I'm going to pull it again and I'm going to see that I can get at least 1 or 2 more slots. Pull it again and I can see I can get 1 more slot. Maybe. There we go. And that is very good now. Cool. And now I nurse my pinky back into good health after it has been crushed by the tension of that belt. I have to measure 8 millimeters. I cannot seem to do this. Okay, and now we try putting it into the hole. And we see that that's approximately as much as we're going to get. So, we put the gloves back on, we will apply the glue, and I will do my best to hold that into place for 5 minutes or so while the super glue sets. 1 glove is on, 2 gloves is on. Yes, this block is definitely not sitting remotely as straight as I would like it to. Screw is to blame. There's always a screw head in the way. It will take some time to heal. So yes, I want to push this in and I want to see. This is mostly good enough. Definitely not hitting the end of the plastic piece, so this is a good start. Okay. Come on. Using pliers to open superglue is always a great idea. Gaseous exhaust. 1, 2, just roughly say 3 teeth worth. Okay, and we let that sit for a moment and we let it drip and we go to the other side. And we go back to the first side and we add some more. And we add a little more and we let that run. One drop more, let it drip, and in we go. Now we let it drip once. I don't want that on the rail. Cool. I do not have a free hand, but we are right at 50 minutes in on the stream right now. So I will hold this in. It's already... I will hold this in. And I will work more on my German pronunciations to keep you all entertained while I keep my hand here and do nothing for the next 5 minutes. Senkkopfschraube. Sinkhead screw. Not sinkhead. Yes, sinkhead screw. Linsenkopfschraube. That's really cheesehead screw. This is our button head variety. Randelmutter. This is like a rosette. It's a thumb wheel. Randelmutter. 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 And then there's Zylinderkopf, which is a cylinder head. Okay, this is... Come on. This is as good as it is coming. What can I say? If this is not tight enough, then... Well, we've got problems. Is the... Oh, that is not on. Ooh, bad. There we go. Well, that's as tight as we can get it, and that better work. Otherwise, we have to get more belt, and this belt is very, very expensive. Like, very, very expensive. If I haven't said that enough. But yeah, this stuff sets very quickly, I will say. Hey, it is what it is. This is looser, but then we can move the motors back to adjust. We can move the motors back to adjust. So we'll give this 5 minutes. We'll give it 10 minutes. But we can do other stuff. Schlitzmutten. Zylinderkopf. Senkkopfschraube, Zylinderkopf. Ooh, this is an interesting one. Yes, this is just a regular M4 nut, so it's... I don't know how the CH sounds, so it's Sech or Sek. Skantmutten. Sexkantmutten. Sexkantmutten. It will have to go. And then it says Flak. Again, CH. Flatch. I don't think German would say flatch, so flak, perhaps? Or flatch? I'm not sure. We will find out. Renee would watch this video, and then this would be still before I wake up. I will wake up, I will see some messages, and he will tell me everything I did wrong. It's a wonderful way to live. We'll coin it the social closed-loop feedback. It's great. It's the closed-loop feedback for social situations. I think it is wonderful. Yes. So however much slack I have in the belt here is how much the motor will have to be slid over there to account for it. It is, yes, just yes, it is very interesting. And it will have to do. But it's cool, you know, you don't have a clamp, or the clamp you have is not working, you print off a part, 30 minutes later, boom. I mean, I'm telling you, I printed the part at 7:30, and I started my stream at 8. And it was still printing, because I had two of them side by side about this far apart, so there was a travel distance increase, so on and so forth. But, you know, around 8:30, we had these, and we started everything. That is drying. We'll give it another 5 to 10 minutes. I will continue looking at the mounting the Z-sheet instructions. So we have this, right? We have this Z-sheet, and I will put the printer forward 90 degrees. But we look at it. We have to clear the cable out. Oh, and this belt is glued in. You're never taking this XY system apart again. We are putting the system together like this. And we have to see why it does not want to go in. In a moment, we have some moments. Yes. I will just give it a few more minutes because I do not want to bump the belt, but shortly I will put the system down like this, and we can start looking at whether this aligns properly or not. Or not. Not. Or not. In short, there's metal here, and there's metal here, and it has to come together perfectly with just, you know, no room for air in between it. Nice push. We'll use M3 by 10 sink screws. We have them. Use 8 of them. I can see where 4 are going to go and 4 more over there. Wonderful. Cool. I have the idea. Okay, I get the idea. Alrighty. Put this down, kind of, in a way. Try not to bump anything too much, not too much more. Try not to pinch the screw, the motor wires. Again, not too much. And we have to find a good place to go with the motor wires. We'll do it like so. I have to tape this motor wire into place until this is all done. Okay. So, here, look. It's very difficult to zoom this in, but over here, there's a gap in the corner. We have to do a push so that there is no gap. And if there is a gap, we break out the file and we fix the problem until there is no gap. Right now, and everything will sit perfectly. There's no room for error here. Ah, I see where the other things go. Wonderful. Okay. Yes, lots of fun. Okay. We check. There's a cutout here. And the cutout might cause a problem, so we start filing. This is the way of the world when you're building a base. Okay. Blow. Try to accumulate the minimal amount of metal dust in our fingertips as possible, and we come and we do it again. Push here. we push here and we pull it from here. We check and it is pretty close. This is on, this needs a little bit. So we file here just a little. And we do it again. That's closer. And how do I phrase this? If we made a mistake, we will find out. Now I need to loosen my pillars from previous because we need to line stuff up in them right now. I'm not loosening much, I'm just a tiny bit. Well, not those. Why am I loosening those? No, those are good. The long ones are good. It's the short ones that I want to have a little bit of give so that this stuff lines up. Yes, and we shall indeed. M3 by 10. I'm going to start with 4 pieces. Well, that's more than 4. And we will begin. Every time we add an aluminum plate, the dice becomes a lot heavier. Do not forget this. Not tightening anything right now, just starting the screws in. Very nice. All the blocks are threaded. Never want to cross thread. Never cross thread. Problem, you fix it. Something's not going in extremely smoothly. You wait and you figure it out. And yes, we have an offset. Lightly tightening. And now I will put on a glove for the left hand. And I will slightly stand this up because my goal here is to lift the plate into place while securing those inner pillars with the wrong bit, of course. With the wrong driver, of course. There we go. The super glue is doing well. That's probably been 10 minutes. Give it another 5 before taking the clamp off. Okay. And we look. See, this is that's how much screwing pressure we have here. Okay, this is flush here, more or less, very close to flush. And there's some gap here, but maybe this is because I filed something more. Okay. Okay. So I've had these pieces on my table for a while, and one of the things, these are going to go at the top here. I'll explain more in a moment. I'm just trying to actually understand where in the instructions this is covered. Anyways, I don't know, but I understand the rough idea, and I can confirm in the CAD model that these things that will obviously fit here do indeed go here. There. M3 by 8 is shown going into here. Three by 8 is shown here. I will figure this out later. Oh, maybe this is back in step 11. Like, alright. Okay, so going towards the end of the step 11 video. Yep, now we see it. Right about 10 minutes into step 11 video. Okay. Okay, so we need to do it like this, sort of. This is probably a bad idea, but it's okay. I need this axis. I think he has it more like this. I will just do it. Cable management. This goes in like so. And step 11 used M3 by 8 cheese heads, and yeah, alright. M3 by 8. Fine by me, I should have plenty of those. Gotta find them. There we go, M3 by 8. Just 4 pieces. Yes, I guess the CAD model does not lie. Okay. So, I will let the video play, but I will just do it. So, you will be seeing some of my head here. Careful not to cross thread. You know, again, loose for now. And again here, one screw through, line up. Oh, that is the wrong screw. I thought I had some contamination. Now we know for sure. M310, you're going back home. Tight, and we hit, and then I back off about a quarter turn, just a little bit. Okay, that concludes step 11, where we've been jumping around a lot. We also concluded step 12 by installing the Z-plate. Now we're partial into step 13. I'm going to start step 13 again. Step 13, we need this piece. The Z-plate holder. Or not the Z, the thing that goes in the Z that holds the print bed. I already installed the rail onto the H piece. Step 13 is showing as needing, so we have the slot nuts, we have the M3x8 cheese heads. I have those here for whatever reason. Yep. It's important that we do not have pressure on the spindle. The nut has to be free and clear. So we're going to, hang on, I'll explain this now. This opening on the end here is for the nut to go in some way. This goes in freely, it just drops in, but in my case, it does not wiggle back and forth, and we want there to be just a little bit of clearance. So I'm going to procure a round file. This is slightly arced, and I have to go around this arc and make space. And we check again. We don't want any metal dust going into the brass nut. This will have to do. It's good. It's fine. I'm not going to file more right now. It will do. Okay. Apparently, if we put this thing right side up, it's pretty heavy right now, by the way. It's not light by any means, and I've still got a desk full of metal for all the other sides. In the video, he's showing, oh, wonderful, this is ridiculously complicated. How this is going to be like so. And there seems to be no right or wrong side to be the top here. And then we have to, there you go, bolt. Do this, but I was told to install the rail first. This is wonderful. Let's see if we can figure something out. I need to consult the model for a minute. Come on, CAD, solve a question for me. Okay. Alrighty. So the rail is, how we say, from the inside of sorts, presumably. Yeah, even if we could, I don't see this happening very well. The rail seems to be sitting here when it's good and ready. Yes. The rail is here. This has to be on the inside. Now, we can't just cut the metal sheet in half and then hot glue it back into place later. This has to be done now, of sorts. Oh, we remember not to bend the spindle by any means. Do not bend the spindle. I think we are taking this thing apart. I will seek clarification later. But right now we are taking the rail off. Look, one screw already came out. Perfect. We'll be going one step at a time here, just as with the instructions. Come on, we got this. Come on, screw. You can do this. Okay. Carriage is out. 1, 2, 3, 4, 5. 6, 7 Schlitzmutten removed. Put the card back in the plate. And 7 screws, which I will also pop back into the plate. And the 7 Schlitz as well. This is more of a cone now. 3, 4, 5, 6, 7. All back into the plate you go. Now we can pretend some items. Here. So now, this combination, intertwined. But how? Hang on, I think I know. We start this here. There we go. That's a way of doing things. And we now have the proper amount of intertwining. And we continue. I check that this looks nice. And fine. We fumble the H piece through here. I'm going to prop this up using one of my printed pieces, which served earlier. Boom. Step 13 calls for, looks like we're using a cylindrical head, M3x6, or a normal socket cap, M3x6, 4 pieces. We're going to secure the H piece into the, come on, you can stay put for a minute. I mean, it can't, but you know. M3x6 socket, or here it's just, it does not say Zylinderkopf, it just says DIN 912 M3x6. I'm good with that. 4 pieces. Turn 90 degrees to face some obscure side. This is a 2.5 millimeter Allen, and we begin. Again, lightly, loosely. This screwdriver is nice. I can just extend it when I do not feel like reaching. Again, very light touch. Light touch. Third. Fourth. Boom. Okay. 4 screws, M3x6, in there. Oh, the aluminum plate is threaded with the M3 tap, and yes. Next victim. I turn the thing, I'm going to click on it. Hopefully it looks okay, but who knows. Now we have to put the linear rail on. This is wonderful. Okay. Please wait. Okay. I'm leaving that on for a moment because I have to put this guy down. And now we get to have our fun. This can lean in some capacity. We can print some sort of holder, I think, to encompass the bottom. Yeah, something. Do it all the way down here, actually, where it won't bend anything as much. There we go, that's holding. Now we put the rail back in. See? In, boom. Line it up. And then this is fun. Wherever my Torx is, okay. Same rules as before. No tightening, 1 schlitzen at a time. Schlitzen, this is a fun word. I don't think we're going to lose the card right now. The beauty, though, is that our Z-screw is in the way. Okay, I'm going to watch how the video shows it. I'm sure the video will have fumbling. This is wonderful. It's not going in very nicely. It's not going in at all. Come on, Schlitzy. Okay, so you're in the home stretch now where you don't want to bend the shaft. Let's see how Renee does it. Okay, I'm going to loosen this stuff so that we have room to maneuver. Loosening the 4 screws holding the H plate in place. Now I have work ability. I can put a flathead on to hold the schlitz in place while I finger tighten the screw. This is wonderful. I can hold the screw and I can turn the schlitz. That's an option as well, but I'm not tightening anything yet right now. If only I wasn't tightening anything. Okay, just loose finger tight. Okay. let's hold this up. You know what would be good at holding this up? A zip tie. Let's get that. Or string. Let's get a nice zip tie. Or string. Zip tie. Okay, the cart is not part of this transaction anymore. Okay, that's holding. Without bending. Without bending. Okay. Now I only have to worry, yes, without bending the screw. Now I only have to worry about the cart. Alright. Hang on. Did I do this backwards? How could I have done this backwards? No, the cart is to the outside. No, we're good. We're good. Plate is from the rear. Motor side. Now we're good. Alright, bottom line, I'm going to do the way I know how to do the Schlitz. Put one in to the opposite hole. I'm going to hold that. I'm going to hand the screw in there. So Renee wrote me, and I can without a doubt say this is the part that he was referring to. It's like, Ray, install the rail onto the H plate first so that you don't have 15 minutes of fumbling later. And I did that, and then I could not get it on. So this is wonderful. And I see now, in very, very clear detail, what fumbling he was referring to. Okay, hang on. Let's go 2 up. Aye. Okay, and we continue up and down. Yes, again, home stretch. We have to be very careful not to damage the lead screw right now. I keep saying that, so maybe one day I will understand that concept. I do not yet understand that concept. Put the Schlitz in. Get the screw. Screwing at an angle, wonderful. Okay, and we continue. Yes, next Schlitz. Ooh. Whoop. And one more. Okay, I'm just going to hold the screw in, and my Schlitz is in the wrong way. This explains everything. Come on, Schlitzy. We got to kick you out now. For all 0 people watching this, all you get to see right now is the top of my head. Wonderful. I have to come from the other side, and I go. I hope I'm not bending it. Okay, we thread the Schlitz from this side and we pull it out. There we go. And now we put it back in with the slot facing outwards and we repeat the procedure. And okay. And last one, right in the middle, slot out, screw in. I would lightly, a little more tighten two sides here. Okay, the rail is going up and down smoothly. It's good. I will turn the shaft. It is still moderately okay. And that is that. Okay. Next step, step 14. Size 10, 2.5 millimeter Allen. I will just consult my chart. M3 by 8. So step 14. Step 14, M3 by 8 cheese head. We have those. We'll need 3 pieces of that. Easy peasy. Allen cylinder M3 by 16. I believe I already have this on the bed. Hang on, let me check how many. Never mind, they want the rest of them, so there's some more pieces in total. M3 by 16 Zylinderkopf. We have more, calls for 6 pieces. We have it. And 2 small special milled parts. Ah, I know these very well. Let us look. This is the first part. This is the second part. See? Look identical, right? No. This part has a pocket on the bottom side, right? It is a counterboard hole. 1, 2. This part on the bottom does not have a counterboard hole. Instead, these 2 holes are threaded all the way through. One is the top, one is the bottom. Very important stuff. We will also, I believe, be using the brass nut in this step, which is part of the motor. Yes. Okay. Brass nut. I think now will be a time to cut my zip tie. Bye zip tie. You have served well, thank you. I will also remove the belt clamp, and the belt is still fairly tight, very nice. And I will prop this part here as so. I have to repeat this portion here. Excuse me 1 second, I want to get some grease. The instructions do not call for grease, I call for grease. I have a syringe, this is with the super lube it's filled. Oh, I just broke it, wonderful. There we go, I have a nice bead. Put it on the inside of the nut here. It's good to grease your stuff. I would wipe it around the inside into the threads. Again, this is not part of the instructions per se. This is what I do. Yes. Wonderful. Greasing successful. With the flange, you have to look at this. Yes. This flange, right, apparently upwards relative to the printer means downwards relative to this. And now we wipe all the extra grease that I just applied to the inside of the threads, because it is now on the top of the nut. Okay. We do it like so, and we have a line. I'm going to do it a little lower. It is holding now. Now, we have some motion, presumably. We're going to screw 3 screws in, these M3s. We have to move this to the top. I'm going to do it this way. Okay. Bottom line, regardless of what the video is showing, we have to screw 3 screws in. I just need to know where. Yeah, I'm just going to use my Torx bit to do it. Let's see. Probably one of the sides. The outer one, for sure. And by for sure, I mean maybe possibly just a little bit. This is a T10. T9. Okay. Come on. This is a T10. Oh. And we rails on. Okay, that's one. Okay, we have to put the dice up on blocks. Slight automotive joke, come on. We have these printed blocks that are being very useful right now. 1, 2, okay. Where are the 3 screws? It seems like we're just going with the sides and the outer screw. So I will just do that, because I have no idea how I would even reach the 4th screw at all. Come on, Scrooge McDuck. We got this. Now I will start it with the bit. And I will come to this. This set also has the flex shaft adapter, so we could have some fun with that, but I choose to do it manually. Right. This screw is going in sideways. This is wonderful. Well, I just hit that, so we'll see what happens. It's threading, that's good, and we'll do the third one. Tighten the second one just a little bit. That is a very, very tight threading. Don't want to do that. Loosening these two. Ooh. I'm like hitting a brick wall here. And it's probably because we're not aligned. And we're still not aligned. Slight amount of force. No, I'll have to. Yep, it's just a tougher thread, hopefully. Come on, don't fall. This comes off the blocks, we lose some stuff. Alright, that's the best I can do. It's tight. This moves fairly well, I have to say. Oh, so if I do this, yep. If I do this, well, still some. Okay, so 3 screws, screws are tight. I'm taking these off the blocks because that's going to fall and hurt something. Let's lie him down just a little bit. Now we're going back. Alright, so now let's bring him to the top. I want to loosen the Z motor. So the Z, the flat back, and 2.5 I believe. That's a difficult one to access. How did I screw that up? Jeez. Plier it. Alright, so the motor is now loose. Now we'll line them down. Okay. Very good. We're now working on these two pieces. I'm briefly going to consult the CAD model. I'm going to say that I don't like what I see in the CAD model, and I'm going to go back to the video. These holes, the narrow side goes together, it seems like. And the cuts go inward. So I guess it is like this. And then I just want to figure out, okay. Yep, and then the pockets are going towards the, I guess this is the bottom of the machine. Yep, okay. Let's do this. M3 by 16. Start with 2. Alright. Start feeding this. I need the head. Okay, we're at surface, backing off. And now we are threading. Okay. I may have done this incorrectly. It would make more sense with the cutouts to be going to the top. Yep. Cutouts to the top so the other screw heads would sit in there. Let's pull this out. Let's do it again. So I imported my CAD model poorly because these are positioned the other way. If I do it like this, and I do it like this, all I'm doing is turning them 90 degrees, we'll be okay. And we have to deburr these holes. Alright, and let's do it again. And backed off. Okay. Mostly tight. Still shaking. The total of 6 screws, so we used 2, so now we're going to use the remaining 4, I'm presuming, to secure to the carts. Loctite is being shown. I'm not ready to go Loctite yet, so we'll just extend, do it, and then when I've confirmed I haven't royally screwed anything else up, I will come back and do it. But yeah, that's not threading very far at all. Not much to thread into in these very, very thin carts. hit, back off. I'm going to tighten these now. Slightly. 1, 2, 3, 4. Okay. This is not very tight. Hey, this is nice. We have motion. I mean, there's some, I can force it, but over here the cart is pretty solid. Hey guys, we have a z-axis and the xy works. Cool. I mean, these belts are tight, you know? It's causing a lot of drag for me to really move this. If I screwed something up there, then we're going to have a lot of fun, a lot of expenses to redo these belts. Yeah, we're good. Go! Okay, so now we need to align the Z motor. Again, the motor is loose. So what we're going to do is we're going to turn the spindle and we're going to move the print bed all the way down in the sense that it's the closest to the motor. Alright. Very close. Look, see, this is the cart all the way to the end. I can keep turning. I don't want to keep turning, so all the way down and then back it off just a little bit. And now, I can still wiggle the motor a little bit. Just want to level it out. We're going to be turning it. I'm just trying to figure out which way now. We're going to turn the body of the motor. Okay. I'm not sure if we want the face of the motor to be parallel to the edge, or if he's trying to counteract the screw positions, but I'm just going to go ahead and start it. 1, 2, 3. There we go. I never tightened these guys down. Oh, wonderful. I never tightened these. The motor's tight now. Let's see if we have smooth motion. There's no catch. It turns. Woo! Man, there's a part of me that just wants to glue an E3D to the blue plate here. Run all the electronics out here and just wire the whole thing. Put the print bed on here. Turn on a power supply and get printing. And, you know, no extruder, just, you know, hot end moving about plate. But we're not going to do that yet. That concludes step 14. Okay, so step 15 is mosquito. Not anymore. Step 15 is mounting the bottom sheet, and this seems to involve electronics. And then step 16 is fan installation and more electronics. And step 17 is more along those things. And then step 18 is tensioning the belt. Step 19 is finally mounting the print plate. 20 is the extruder, 21 is the hot end, more hot ends, more hot ends, ooh, more hot ends. Then cabling, and that's really it. Hey guys, we're getting close here, but I have to wait for one part to arrive so that I can do the hot end mounting. So that's still a few steps away. So I guess my next stream is going to be the beginning of electronics installation. And I guess all that stuff I just said, I guess we can do that. So for the next stream, I will prepare... Well, I gotta talk to Renee about how tight this is. Yes, that's tight. But yeah, I can prepare the electronics, I can prepare the Cohesion 3D mini board. I can get just a 24-volt power supply. I do have the nice power brick, but I'm not ready to play with that yet and plug that into American Power Outlet yet. Ooh, I like this. Motor's going to need a lot of power. That's why we're using full-size NEMA 17s here. We're gonna be cranking the current to them, I can only imagine. Yep, we're doing well here. Woo! Yeah, so yeah, I can prepare the Cohesion 3D Mini. I'll have to dig up some Trinamic drivers, which I have on some other machines. Woohoo! And I'll get just a nice LED style power supply. Ooh, and a Raspberry Pi. And we can mount all this onto this here is the electronics mounting plate, which is the here in some orientation. This is the very bottom of the printer. So there's a bunch of holes here and it's still got the nice oil finish. Yes. So we'll be mounting all the electronics onto here. And yes, this will be next time. If I recall correctly, today's Tuesday. I don't stream on Wednesdays because Dustin does his live stream show on Wednesdays. So yeah, nice break, and then we get to do all the electronics. Alright guys, thank you for watching. Have a good one. Yay, we're getting there. It's close. It's all the little stuff now. You know, the stuff I'm supposed to be good at. No. Alright, bye.